Let's go ahead and talk through this quiz question. So we're asked to determine if the subset of R3 given below is a subspace of R3 by checking the three properties. If you remember, we sometimes have this zeroth property where we check if the set, so let's call that set H, we check if H is a subset of the given space. So in this case, it would be checking if it was a subset of R3, but we're told in the problem that it is a subset, so we don't actually have to check that that's true. So we're told in the problem that this is true. So that one's for free. So let's go ahead and check the other conditions. So my first condition that I need to check is that 0, whatever element is 0 in my big set, so 0 in R3, that 0 vector, is in H. So that's what we're checking. I'll put a box around it. That's what I need to show. So I know that 0 vector is equal to, I'm going to write it in a row notation because that's the way that we've written things up here. So it's equal to the vector 0, 0, 0. And to show that it's in the set is all vectors where the first thing plus 2 times the second thing minus the third thing is equal to 0. So what I'm going to do is I'm going to take my first thing plus 2 times the second thing minus the third thing, and I need to show what those are equal to. So that's just going to be 0 plus 0 minus 0, so that's just equal to 0. So I showed that I really do satisfy that condition. Therefore, 0 vector is in H. It meets all of the rules it needs to be in H. So now let's move on to our second rule here. The second thing we need to show is that we're closed under addition. So I need to show if you have V and W in H, then the sum, V plus W, is also in H. So we're going to start with two vectors that are in H. So V and W are in H. And now I'm going to write down the rule that they must satisfy in order to be in H. So I'll say then, or so, V has to equal something of the form x1, x2, x3. I'm allowed to use whatever variables I want. So maybe I'll use something like V1, V2, and V3, just so I remember that this is the V1. And I know that it satisfies the rules, it satisfies that rule to be in H. So the first thing plus 2 times the second thing minus the third thing has to be 0. And then the same thing for W. W, maybe I can call that some W1, W2, W3. And it has to be the case that W1 plus 2 W2 minus W3 also has to be the 0. Now I want to check that the sum is in the set. So when I do this, I want to explicitly write down what that sum is. So I'll write V plus W equals, and now this is my V vector and this is my W vector, so I have to add those as vectors. So I'm going to get W1 plus V1, or V1 plus W1 for the first entry, V2 plus W2 for the second, and drew my long letter, V3 plus W3 for the third. And now I need to sort of write in words here what I'm going to do. I'm going to explain why this new vector that I've written down, this V plus W, is in H. And if we go back to the beginning here, to tell that something is in H, you have to show that it satisfies this rule. The first thing plus 2 times the second thing minus the third thing has to equal 0. Now I don't know that that equals 0 yet, so I need to check that that equals 0. So I want to check to take this first thing. So the first thing now is just a V1 plus W1 plus 2 times that second thing minus that third thing, And what I want to show, so I'm going to write a big want to show here. I want to show that this is equal to 0. So really when I'm doing this, I wouldn't actually write this step down yet because I don't know yet that it's equal to 0. That's what I'm trying to show. So I'm going to kind of leave that off to the side there. So I'm going to only write down things that I know this is definitely equal to. And my goal is to say, okay, it's definitely equal to something, which is definitely equal to something, which is definitely equal to something, and hopefully I get 0 somewhere along there. But what I can use is I can use these two properties we had up here that told us why v and w were in my set. So if I take v1 plus 2v2 minus v3, I know that's 0. And then w1, 2w2 minus w3, I know that's 0. So that's where I'm going to get my two zeros from. So let's go ahead. I'm just going to expand this out first. So this equals v1 plus w1 plus 2v2 plus 2w2 minus v3 minus w3. And then maybe I'll write all of my v1s first. Or sorry, all my v's first. So I've got all the v bits, and then I'm going to use my commutative property to put all the w bits next. And now I see that I have, get rid of this 0, one extra step, these 3 are going to be 0, plus these 3 are going to be 0. Those were my rules I had up above, and therefore we get that this equals 0. So I showed that my new v plus w, it satisfies the rule that the first thing plus 2 times the second thing minus the third thing does in fact equal 0. So we can conclude that that v plus w thing is in H because it satisfies the rule for H. Okay, so looking at the next part, it's going to be pretty similar. So I want you to kind of recognize some similarities here. The last thing I'm going to show is that if v is in the set, and c is just any real number, then c times v is in the set. Oops, I wrote r instead of h. That's my goal here. So again, I'm just going to let v be in my set and c be some real number. Then, because v is in the set, v has to equal, again, we'll use v1, v2, v3, with v1 minus 2v2 plus v3 equaling 0. So then cv is equal to cv1 plus cv2 plus cv3. And now we got to check, does this satisfy the rule that puts me into my set? So the rule says that if you take the first thing minus 2 times the second thing, is it minus or plus? Sorry, plus 2 times the second thing, that should have been a plus there as well, minus the third thing, I wrote this all sorts of wrong. So that was my rule that I got for H in the beginning. That needs to equal 0. So I've got first thing here. So for this vector, its first thing plus 2 times its second thing minus its third thing. If I can show that's 0, then I know I'm in my set. But I can see that this is definitely equal to c times v1 plus 2v2 minus v3. And so that's 0 from up here. So that's c times 0, which is 0. Therefore, c times v is in that set H. So now I showed that 0 was in the set. For any two things in the set, the sum was in the set. And for anything in the set, a scalar multiple is also in the set. Therefore, I can conclude that H is a subspace of R3 because it satisfied each of those properties.